Welcome back to my Screeps Let's Play / tutorial series. First up, I would like to elaborate on some of the code and files we wrote last episode. In particular, the screeps.d.ts and in this file, the question marks. Any file that ends in .d.ts is a type declarations file and is used to tell us how code is meant to be typed. In our case, we can see creep memory must contain a variable labeled role, and role must be a string. We can also see some other variables inside creep memory. Those with a question mark, these two here, after them may be undefined. That is, not every creep's memory needs to contain that variable. We have placed them in there to standardize what variables a creep may have, such as building. That's used on builder creeps to tell us when that particular creep is building. The bracketed variable up the top basically just says creep memory can have any key, like role or building, and that key, the key's name is a string, and that key may have any type of variable. So like role, it might be a string like harvester, or like building, it might be a boolean. This prevents errors when we define a key on a creep that doesn't exist in this definition file yet. We don't need that line, but it will stop errors when we're coding up something new. Ideally, we would add the new memory variable here once our code is working though. Or even more ideally, we wouldn't have the coverall at the top and just only use variables defined, adding new ones when we want to code something new. Now that we've cleared those factors up, let's move on to our goals. At the top of the list, we'll be cleaning up the main file. This should be as empty as possible. Today, we're going to move the creep spawning logic into another file, as well as the logic that powers towers. While we're at it, we will make the towers logic work for any tower, rather than copy and pasting in the IDs. The spawning logic will also get an upgrade, to have some dynamic logic for the number of creeps to spawn at any given time. We will also add a repairer role. This role will have the responsibility of keeping the tower filled with energy, and secondarily, they will repair any structures that are damaged. Finally, we're going to be giving the harvester role an upgrade, in regards to making them able to target the remaining structures that need energy, and adding a prioritization system to their targeting. So, let's get started. We're going to want to move this tower logic. Yes, let's do that. So, we'll make a new file called structure.tower. We will take the code here. Yeah, we'll just Control X that and in here. We have to rewrite this. So we want let structure tower. Oh, actually, we'll call it structure towers because it's for multiple. And we'll put a run definition. We'll go towers, and that'll be a structure tower array, so a list of towers, and this will be a void method. Right, and then we export default structure towers equals run. We know what type that is. There we go. Right, towers dot for each tower. We want to find the closest damage structure and the next thing, really. Pretty sure that works. Yeah, that looks good. Nice. Cool. That's that working. So if we go back to main now, we can get rid. So we should probably go over what we've done here a little bit. So I should be explaining my code a bit more soon. This here is saying that the structure towers variable is going to be an object that has a function named run, and that function takes one input, towers, and that tower is a structure tower. So we're going to have a quick look at this. Structure tower is just one of the structures you own of the type structure tower. And we're having a list of those, so there'll be, more than one of them probably. And we're saying that's a void function, so it just doesn't return anything. This just runs and exits, and it's all good. So next up, we export the structure towers, and that structure towers is this object. So we got the run function that we said it would have, with the towers variable that we said it would have. And for every tower, so for every tower in that array, we are running some code. So we find the closest damage structure. So we call the tower position to find closest by range. We're telling that to find structures, and we're filtering that structure to any structure that has less than full health. And then if there is any structures that are less than full health, repair it. And then next up, we find the closest hostile. Again, very similar logic there. And we don't check its health or anything. We just want to see if it's alive. And if there's any alive, we attack it. Nice and easy. Cool. That's all we really need to know. So that's what does that there. So let us... And next we have to find all the towers that exist. There is a way to do that. Game.structures, if we look at the documentation, is a hash containing all of our structure IDs as hash keys, which is great. What we need is the structure ID of the tower, right? So we could just filter this down. That would be one way to do things. So if we grab to just towers. Yeah, so let's do that. Let's okay, so we're gonna go structure towers equals we're gonna do the lodash.filter game.structures. We got a collection, and then we need a predicate. So yep, structure constant. That's all good. Return. So if the tower, so if the structure is equal to a tower, we're getting the tower structure tower IDs. We should probably change it to IDs. All right, return structure dot structure type is equal to structure tower. There we go. Bam. We got the tower IDs. Now, a small problem. This code doesn't actually know that those are tower structures, even though we know it is. All we know is we got the IDs of a structure constant. Actually, it counts as a structure. Can we return that as structure tower? No. There we go. We can do it like that. Bam. All right, cool. So since we know they're structure towers, we'll just put in the as structure tower keyword there, and that'll tell us that they are. That's we know they are. We have checked their type right here. It should be all good. All right, so yeah, we need to import next. Import structure tower from structure tower, and then we go structure tower dot run structure towers. We'll probably rename that to towers. That makes a bit more sense, and we're all good. So now our towers should repair any nearby buildings and attack creeps. That's great. Commit that code down. So boom. Move refactored tower functionality. Moved tower logic into its own file and globalized it. Next, move spawning logic into a separate file. Let's work on that. So we'll create a new file. We'll call it like spawn.creep. Another valid name might be structure.spawn, but for now, I'm specifically working with creep spawning. So I feel like calling it spawn.creep. And yet again, we will want to take a bunch of this logic and move it into there. And that will get our main file a bit closer. All right, and we'll do the same thing again. Let spawn creep equal that run void, and we'll go export default spawn creep equals this run. Bam. Nice. And we gotta start moving this logic in there. So first of all, what things can we do to make this a bit better? So let's have a look-see. We don't need to pass in memory roles. So we might call this spawn creeps. Spawn creeps or spawn. I like that more. This here strikes out to me as something we can fix. We can change that to be, we could change that to be the spawn. Yeah, we'll make that the spawn. Structure spawn. There we go. Oh, whoops. Bam. Okay. That's one thing we can fix up, and everything else there looks pretty good for now. I'd like to make the body parts like automatic later too, but that's a bit complicated for right now. So for right now, we'll just we'll start writing this back. So we can copy and paste that. And that's all good. And we'll add in a little to do for ourselves here. To do, make a debug mode used to decide if logged. We'll come back to that at a later date, but we'll make it so there's like an if check that checks if like a debug mode is turned on and outputs these sort of log messages. All right. Next up, we want to copy this stuff. So if harvester's length is less than 2, spawn a harvester, except we'll change this here to be spawn.spawn creep. And the same down here, because all the rest of that is good. Spawn.spawn creep, nice. Cool, cool. So that's all of that fixed up. And we just got this down here. So if spawn is spawning, spawn.spawning.name, spawn.roomVisual.text, spawn, and we just replace all that with spawn. That code's a bit better now. A bit less step by step, a bit more easy to read. And it's all good. We can import that into main. Import spawn creep. Let spawn creeps from spawn.creep. And then we need to add that down here. Now, this is where things get a bit interesting. So we could do pretty much the same code we have there, but for structure spawn. But since we're gathering two different structure types now, it might be easier to do something a little bit different. Like maybe say constant my, so we know that game.structures returns all structures. So what we could do is constant my structure, it returns their keys, equals object.keys game.structures. And then we could do my structures which is a structure constant array. So structure constant, what's that? Structure constant is any buildable structure constant and any of those. A buildable structure constant is like an extension, road, spawn, storage, tower, you know, all those sorts of things. Like, it's just all the structures you can build, and there's more things it can be, but now it's not too important. We're just storing basically any type of structure equals my structure keys dot, we don't want to filter it, we want to map it, and we'll take the key, we'll go game dot structures key. Nice. So now we've got all the actual structures, so we can do logic on that. So what do we want to do? We want a list of towers, so we'll comment out this code. And we'll go constant spawns equals structure spawn array equals new array. We'll go constant towers equals structure tower array. And we'll, for every structure in my structures, we're going to push to these arrays if it's that type of structure. So if struct dot structure, it doesn't know what it is. I know what the problem is. That's meant to be of the structure of my structures. Very important. So in is like the key of an object, and of is the object itself. So we were grabbing like the object's name, but not the actual object when we're done in. We want of. So if struct dot name, goddamn AI, structure type is equal to structure spawn, nope, that one, and spawns dot push struct as structure spawn. There we go. Bam, easy peasy. And then same deal down here. If struct dot structure type is equal to a tower, then we want to towers dot push struct as structure tower. There we go. Now the AI knows what I want to do. Hell yeah. That's good shit. The structure tower dot run towers. So to spawn the creeps, we'll do spawns for each. Spawn to spawn creeps dot spawn. Spawn. Bam. Done. Magic. Fucking incredible work. That will spawn all of our creeps, and that will do all of our towers. Excellent. So we've marked them off of our to-do list now too. But we've moved the spawn into a separate file. We have not set up simple dynamic auto spawning of creeps though. That is a whole nother doozy. So let's first up commit our code now that we've got some code. Actually, hang on. What we should do is test that that's working. So npx tsc, compile our code. Excellent, that's our code compiled. Head over here. We have enough to spawn a creep. Let's just take a creep and kill him. And we should automatically see it spawning a new harvester. Hell yeah, it's working. So our spawning code still works. Good news, good news. All right, so now we can commit our code. So we'll stage all those changes. So we done what? We removed a whole bunch of code and added in a tiny bit of code. Actually, there's one more thing we can do. We'll get rid of that commented code for the towers because we don't need that. We added in a spawn creep class. Refactored spawning logic into its own file. Sorry, I call that a class. I'm just too used to JavaScript. Java. Nice. Alright. Back up here. Simple dynamic auto spawning of creeps. Let's go have a look at spawn.creep. How can we adjust this to make it automatically spawn a certain number of creeps? Well, the big thing that jumps out to me here is these hard-coded numbers. We should try and make those numbers dynamic. That would be a great start. So how can we do that? Well, what we should do is edit the actual roles. Yeah, we should edit the roles. So let's go and have a look at role.harvester, builder, and upgrader. That's our 3 roles right now, right? Yep, cool. The role.harvester, let's add. So we're going to have the function num_harvesters, which returns a number, and we're going to have the room because we're going to check how many sources are in the room to decide how many harvesters we're going to have. That makes sense to me. So let's take this. We're going to do comma num_harvesters. We'll just do return 0 for now. Let's get rid of that error. And we'll get rid of that because we know what that is. Cool. All right, so first up, constant sources equals room.find sources. That sounds good. It knows what's up. Constant num_harvesters equals 0. It's a number. And we'll return num_harvesters. So what are we going to do? We've got to do some math from the sources. So I'm thinking we do like 3 harvesters per source. Sounds pretty good to me. So num_harvesters plus equals sources.length multiplied by 3. Oh, and we got to change it to a let. Whoops, whoopsie daisies. And that should be good. So we need to prioritize harvesters over everything else. So I don't really think there's any other way to do this right now. And we want to keep our logic pretty simple, right? We're incrementally building on our code. So that sounds good to me. Next up, let's go to spawn creep. We will import role harvester. And we'll do if harvesters.length is less than role harvester.num_harvesters. And what do we need to put in? The room. Spawn.room. Oh, there we go, because we have the spawn that we're spawning in, so we can get the room from that. Then we spawn a harvester. Next up, let's do the same thing for the builders. So we want a num builders, and that will be, again, we're going to need the room because we're going to need to know how many construction sites are in it. And this will be a number. We'll add that in down here. Again, we'll just do return. Actually, we'll let num builders equal 0. Return num builders, and then we'll put our logic in between. So constant targets equals room.find construction sites. Yeah, find construction sites looks like the correct thing. Yeah, find construction sites. Let's go with that. There are finds one of the following constants. Find creeps, my creeps, hostile, spawns, construction sites. There we go. That's what we want. Yeah. There we go. So don't forget the Screeps documentation exists, and you can look that up. But I'm decently familiar with the code we're writing today, so I just forgot what exactly I was doing there. All right. So you can also, if we have the Screeps documentation built into the thing when you control and click on something, it'll take you to it. Anyways, let's say num builders plus equals targets.length divided by, let's say for every 5 targets, we'll add a builder. Math dot. So if there's 4, do we want to floor or seal it? Seal, because it might not add any. Cool. Yeah, easy. So if there's 1 target, we'll have 1 creep. Easy. There's 9 targets, we'll have 2, etc. There's 10 targets, we have 2. But we also want to do... Alright, so I'm thinking if a construction site is difficult to build, we should have more creeps to build. So let's have 2 more things here. We want a constant max builders equals, let's just say 5. We only have 1 room right now, so again, we'll keep the logic simple. We don't want more than 5 builders, even if we have lots of construction sites, so they're really hard to build. Next up, targets. Let construction accumulate. Let accumulated construction cost equal 0. Nice. All right. And then, so for each target, we're going to target dot progress total. All right, we're going to do some math. So we're going to figure out how much cost is left remaining to build, right? And the higher that number is, the more we'll add creeps. So for every, say, 1,000 cost, we might add a Korean 15. So a road will cost 300 to build. So maybe 1,500. That'd be 5 roads. For every 1,500, we will add an extra builder. So let's go accumulated cost plus equals that. And once that's added up, num builders plus equals math dot, we'll do a floor this time, accumulated construction cost divided by 1,500. Bam. So for every 1,500, we'll add another builder, but we'll only add it if it hits that 1,500 limit, because it's rounding down that number. So between 0 and 1,499 building cost, no extra builders. But we get up to 1,500, we get an extra builder. Cool. Rad as hell. I return the number of builders. But we want to add a ternary here. So number of builders, if number of builders is less than equal to max builders. So if that condition is true, we want to return num builders. If that condition is false, we want to return max builders. So what is this? So read this like this here. So if the number of builders is less than or equal to max builders, so say we got 4 builders calculated from this logic here, then we return 4. If this would be 7, and our max builders is 5 as we have it up here, then we return max builders, so we just return 5 instead. So we don't ever want more than 5 builders in this particular formula, is what we're saying. So I think that's a good formula there to have for the number of builders. Again, you can change this for your own code, but that's what I'm doing. Upgraders. This is a tricky one. So what I would like to do for upgraders actually is base it based on how many other creeps are in the room. That's a little tricky though. So run nothing for now. No, sorry, not run. Num upgraders. Number. So we're just going to keep it really simple. We are, oh, here we go. here we go. This was a tricky idea. We could calculate how many creeps are in the room. Alright, so fuck it. Let's make this let's make this a little more complicated. We're gonna refactor this in a later episode, but for now, we're going to make number of upgrades, take a room, and so if the room is equal to room, the room provided, then let creeps in room total equal 0. Creeps in room total plus plus. Adding 1 to that. So every so this is very bad code right now. This is very inefficient. It's checking every creep that we own in every room we own, and only if it's in the same room we're adding to the thing. So we're gonna refactor this code later. Let num upgraders equal constant max upgraders equals, let's say 5, and that can equal max upgraders. So num upgraders minus equals, so we're going to say it's creeps in room total divide by every 2 extra creeps we have less upgraders, maybe by 1, and so we'll make that a math dot floor, so only for every second creep will we reduce it. But what we're going to do here is going to add a second variable, num harvesters, and that'll be a number. And what we're going to do is creeps in room total minus num harvesters we're going to do that, and we'll return num upgraders. So, and we'll chuck that in brackets too. So the result of creeps in room total minus harvesters, so we're not counting harvesters, so for now it's just how many builders are in the room, divided by 2 is how many we remove from number of upgrades. So for example, say I have 10 creeps in the room, and 4 of them are harvesters, 6 of them are something else, like a builder. That'll be 6 divided by 3. So 6 builders divided by, 6 builders divided by 2 equals 3. Number of upgraders will be max upgraders minus 3 is 2. So we'd only have 2 upgraders in that case, for example. So that's how that works. Cool. Nice. And then we just implement that into spawn creep. So builders.length is equal to, we need to import role builder and import role upgrader. Nice. We work down here, we add these in now. If builders.length is less than role builder dot num builders, what am I working with? Spawn dot room, and then same deal with the upgraders. If role upgrader dot num upgraders spawn dot room comma role, we'll just use the role harvester dot num harvesters here to calculate how many of those we're going to have. So we know how many harvesters we're targeting in the room. We'll just assume we have as many as we want. Even though that won't always be true. It'll be close enough most of the time. Alright, nice. That looks like some good code. So, we'll just quickly head back to the role upgrader. To do make based on an actual creep count. An actual provided creep. So we'll make a utility class that counts the creeps in each room or something and tallies them up for us. we'll do that later. I mean, that will be an actual class, not just me saying words and meaning something. Cool. All right, that looks good. We should compile that and test it. So compiled, and let's have a look-see. Oh, it's spawning new harvester, and that's what we're expecting. We should be spawning more harvesters because we should want like double the number of harvesters we had. So that's good. We spawned one as one died. That's unfortunate. Cool. So things seem to be working. Let's commit that code and add functionality. Now we might make this stuff next episode. This has taken a bit longer than I thought it would today. And then maybe we can play a little bit of Screeps while we have a look-see at that. So let's do some building. We're gonna need some extensions. So let's place some of them around the place. So we're gonna want boom, boom, boom. Let's place them around there and here. Nice, cool. Near our sources, not too far away from them. And what else? We could use a tower. Again, we should probably have that in between our sources. We'll chuck it there. And we'll add some roads too, maybe. But we'll just real quickly, how much does the tower cost to craft? 5,000. Wow, that's crazy. So yeah, let's build some roads. Just a couple of roads. We'll add more to go over to that upgrade bay over there later. For now, that should be quite a bit to construct. It is trying to build more and more harvesters. Surprised it hasn't maxed out the harvesters yet. That must be the last one. Cool. Rad. Rad as. Alright. That should be all. Thanks for watching. Don't forget to give me a like and subscribe if you enjoyed the content, and I'll catch you on the next episode.